Alrighty, let's get started. So we are now in week 14, and week 14 talks about structures, which is going to lead us to objects, which is the topic for next week, classes in object-oriented programming. And let's get started with structures. So first of all, what's a structure? It's a way for us to organize a bunch of variables into some kind of an entity. Okay, so this was the early days before they had objects. Okay, so this is pretty much as far as the C programming language left, and the improvement upon the C language after that that came with C++ was they added objects on top of the structures. So what are the structures? Well, it's some kind of a named entity where you can bundle a bunch of things together, a bunch of variables. Okay, so for example, we can have something called parts, which is going to have a property called part name and different other properties like maybe count, how many parts you have and how much each cost. I mean, how many of each part you have and how much each costs, maybe at a total cost for all the different properties. So the difference between an object or a class and a structure in C++ is that structures don't have functions. Later on, they started adding functions to them, but in the beginning, as far as the development of the language goes, it was just variables, right? So it's just a way for us to group a bunch of variables together. And if you have taken Java class, this should look very easy because Java pretty much throws you, at day one to start using objects. So I highly recommend after this class to take Java before you take your data structures class, just to get more comfortable with objects, and then you can take the CSIS46, which is the data structures C++. Okay, so anyway, let's see what's happening with this code in here, right? So you have your main, and in it we have a structure called parts. A structure of the parts type called part. Okay, so struct parts is just this thing on top in line 6, and we're going to call it part. So this is similar to how you declare a variable to say int count. Instead of saying int count, we have struct part. So struct part is the part of the int, which defines what kind of a variable this is going to be. Okay. And then in there, what I can do is I can change the different properties of this particular part, right? I can change the part name to bold. I can say there's 20 of them. There's that each cost this much, and then I can even calculate the total costs for the bold part. Okay? Any questions on this stuff? Pretty basic. Okay. You can use these to do inputs and outputs as well, right? So different variables. A couple of integer variables, a couple of float variables, and there's a couple of examples in there to in this case we're declaring a variable called autoparts, which is going to be of the structure type called record, right? And we're going to access the properties or the variables of this particular record using the dot symbol. And that's how we do it in object-oriented programming. That's how we do it in Python. That's how we do it in Java. And actually, when you get to the second C++ structure, the second C++ class, you're going to see that C++ allows another way to access these. Okay, other than the dot, there's like the dash and the greater than sign, just to make it more, confusing. So just an example of how the user can enter some information into a structure and then do some kind of a calculation with the structure. Properties, storing them into one of them called total cost, and then showing it as an output, right? So input and output with structures, then structures and functions. In the structures and functions example, I have a type def struct cylinder. So the type def tells it that we're going to create some kind of a data type or some reserved word called cylinder, which is going to be another way to say struct cylinder. So instead of saying struct cylinder to declare a variable like we did up here, right? We have to say struct record and then the variable name. Then I can just say cylinder and that will replace both of these, struct and cylinder, to declare a variable, right? So in here we're going to have can1 is going to be of the cylinder type, which is a structure, right? And then later on in line 21, again, I'm declaring another variable. Okay, so the main thing here is, how to send a structure into a function, and you can also do structures as pointers, which is the next example, right? Functions example 2, structures and functions example 2. You can see that again we have another structure called cylinder. We're going to create a variable on line 13 called capital cylinder, which is going to be the same way of saying struct cylinder from now on. And then I'm using that in lines 15 and 16. In line 15, I'm creating a pointer to a cylinder variable. And in the other one, I'm just saying that it's going to have a cylinder variable. And by the way, this syntax can be used in your other functions that we learned up to this point. You can either say, for example, int, in the parentheses as a parameter, you can say int num, or you can just say int. Both ways work. You don't have to specify the variable name. Okay? Same thing with arrays also. You can put just the square brackets instead of putting the array name, and then it will work the same way as putting a variable name in there. Okay, so in this case, we're sending a cylinder into a function. Why we're doing this? Well, because these structures can be of many different variables, right? And actually later on when we start making, when you get to data structures, you're going to start creating your own objects, which are basically a bunch of you think of a structure, but then add functions to it, right? So that's an object. And since these structures can become really big and very taxing to move them around in memory, that is one of the reasons why we have pointers. So you don't have to move things around memory. You can just tell a variable in one function, hey, look at this place in memory somewhere. Okay, so that's how we're sending structures, or one way to send structures into a function, right? And then pretty much the syntax is the same as you would send a normal variable of like the primitive types, like an integer or a float or a double. Okay, so you have in line 19, you have a variable called can. In line 21, you have the %can, which is you're sending the memory address of can into the function, right? Which is going to be received by, this parameter on line 32 called can1, right? Oh, and there's the little dash with the greater than symbol that I was telling you on line 34 and 36. That is another way to access. So if you have a variable which points to a structure, in order for you to access the properties of that structure, you can't use the dot. You have to do the dash and greater than. Okay, that's just the C++ syntax. Okay, and then again, if this would actually change, you could rewrite this instead of writing it as a pass by pointer. If you rewrite it to do a pass by reference, then in this function here on lines 34 and 36, you can use the dot. So if you pass by reference, you can use the dot to access the variables that are inside of the structure, also known as properties. And if you're using a pointer, which you're seeing here, then you can't use the dot, you have to do the dash greater than. Okay? So that's pretty much structures as far as I can tell you. Oh, of course you can make arrays of structures, right? Just like you can have an array of integers, you can make an array of structures. But that's more of a topic for the next class that's coming up, right? The CSIS46 class. One of the first things that I'm going to make you do is you're going to create an array of structures. But it's not actually going to be an array of structures, it's going to be arrays of classes. And a class is basically just like a structure, but we add some functions in there as well. Okay? Any questions?
Yeah, based on how you pass that structure in,
Yep.
you either use the dash greater than or the dot, but you can't mix them up.
No. So, okay.
Only one is correct.
Correct. So, one more.
On the usage and how you
Yeah, so in line 32, you can see that, right? In line 32, I'm doing an asterisk can1, right? So can1 is a pointer to that structure that we define up here, the cylinder, right? Since it is a pointer, the way we're going to access these different variables that are in the structure, right? The radius, the length, the section, the volume. The only way to access them, according to the C++ syntax, is using this dash greater than, like the little arrow thingy. Okay, you could rewrite it another way if you change this asterisk to an ampersand, right? Make it a pass by reference, and then change the syntax here. So remember how there were some examples where we did pass by reference. Look at those. Change this thing to a pass by reference, and then you will not have to use the little arrow thingy. You're gonna have to use a dot. But yeah, then only one way works with one of them, right? Yeah, that's that. Any other questions? Yeah. So to me, again, this is some of these a little bit more confusing things with C++. Is, well, why do we have to use a dash and a dot? Couldn't you just make a dot for both of them? No, we're going to have a slightly different syntax for whatever you're using, and that's why some languages simplify these things. There's just no pointers. Like for example, in Java, everything is passed by reference. If you're going to be passing an array into a function, you don't have to do asterisks or anything. It knows it's going to be passed by reference. Same thing with objects. If you're passing an object into a function, it will automatically know that you're passing a reference, not the real object. Anyway, so that is functions and structures and a little bit of classes. And I don't know if I had anything on top. Yeah, I pretty much told you these things. So what do you have to do for today? Since we're on week 14 and assignment number 72 already, I figured to give you a little easier one, which is basically just type these structure examples and get it to work. Turn them all. Unless you want something else more challenging, I can come up with that for you. Anyone? No? Nothing? All right, fine. Be that way. So yeah, that's the plan of action. So we learned a lot of things in this class, right? The input and the output, the selection, the repetition, the functions, pointers, arrays, files, input and outputs. Now you got the structures and classes and object-oriented programming coming up next week. So yeah, I think I have pretty much finished with everything that I wanted to tell you except the objects, which is coming up. Could I made this harder? Yeah, probably. I could probably throw it like an extra hard final project at the end. But for now, I don't think that's what's going to happen, right? Make sure you do your final project. See how many people have turned it in already. 10 out of class of 56. Something like that. So, huh? Yeah, I have enrolled all of you in the same class section online. That's why it's got this funky title. But yeah, there's like in this course shell here, there's close to 60 students. So there are 50 of you that are maybe listening to this video. Turn it in. Start turning it in so that And by the way, it's all based on the assignments you were supposed to have done up to this point. I was even actually contemplating making the final exam be just the questions for the extra credit ones. That way, you'll be like, wait, what? I could have just... No, that's probably next year or something. But not for you. Okay? So, yeah, you have a pretty easy final exam. Turn that thing in. It's worth 100 points. A lot of points. Yeah. Question? Going once, going twice, 3 times, 4 times. Alright, that's all I have to tell you, and I'll post this video for you.